You ever see a giant excavator just effortlessly scoop up tons of dirt and think, how? Where does that insane amount of power come from? Well, it's not magic, folks. It's hydraulics. And today, we're going to pull back the curtain on the incredible and sometimes kind of dangerous force that's hiding inside these simple-looking parts.
I mean, look at this. It looks like a crazy tangle of black snakes, right? But what you're actually looking at are the arteries of a modern mechanical beast. These hoses are pumping fluid under unbelievable pressure. This is where the machine gets all its muscle.
And that really gets to the heart of it, doesn't it? How in the world do you contain and control a force that's strong enough to lift buildings inside of what looks like a simple rubber tube? Well, the answer is actually pretty elegant and incredibly powerful.
So, to get our heads around this, we've got to start with the secret sauce itself, the fluid. This is where the real magic happens.
All right, so what exactly is a hydraulic system? At its core, it's a closed loop that uses a special fluid, usually oil, that can't be squeezed down. It's incompressible. So when you push on the fluid at one end, that force travels instantly to the other end. And this is where things get really, really clever.
The best way to think about it is like a liquid lever. You apply a small force to a small area, and because of how the system is designed, you get a massive force out of a larger area somewhere else. A tiny little push becomes a mighty shove. And that right there is how one person can sit in a cab and control a 50-ton machine with just a couple of small joysticks.
Okay, but for this whole liquid lever thing to work, you need some incredibly strong arteries to carry all that pressurized fluid around. And that brings us to a super critical component, the mighty hydraulic hose.
Now let's be clear, we are not talking about your average garden hose here. Not even close. These things are absolute marvels of engineering, designed to handle pressures that would shred normal tubing in a split second. Each one you see here is purpose-built for different pressures, temperatures, and jobs. So let's break one of these down, because what's on the inside is what really counts. First, you've got that inner tube, which holds the fluid. But the real hero of the story is this middle part, the reinforcement layer. This is often made of braided, high-tensile steel wire. Think of it like a steel skeleton that contains all that immense pressure. And then you wrap the whole thing in a tough outer cover to protect it from the outside world.
So you've got all this incredible power packed into these hoses. But what happens if it gets out? Well, the results are not pretty. That pressure has to go somewhere, and believe me, it escapes violently.
Let's start with a pinhole leak. Sounds harmless, doesn't it? A tiny little hole, but it's actually one of the most insidious dangers. The stream of fluid shooting out of that hole is almost invisible, but it's moving so fast it can slice right through skin and cause a fluid injection injury. And that is a massive medical emergency.
Then you've got something called a coupling blow-off. If that metal fitting on the end isn't attached just right, the pressure inside can fire it off the end of the hose like a cannonball. You're talking about a heavy chunk of metal turned into a literal high-speed projectile.
And then there's the one that looks like something straight out of an action movie, the whipping hose. If the hose itself breaks away from that fitting, the escaping fluid turns it into this wild, uncontrollable whip. It'll thrash around with enough force to cause some serious damage to anything or anyone in its path. Okay, so how do you stop these nightmares from happening? It all comes down to meticulous maintenance. It's not about waiting for something to break. It's about having a strict program of inspecting and replacing parts and making sure only trained pros do the work. And here's a huge one. You can't just mix and match parts from different companies. That hose and that fitting, they have to be designed to work together as a perfect team. All right, let's switch gears a bit. Hydraulic systems aren't just dealing with smooth, steady pressure. You get sudden shocks, you get spikes, you get moments where the machine needs a huge burst of power right now. So how do engineers handle that? Well, they came up with a really clever device that acts like a shock absorber or even a rechargeable battery for the system. It's called an accumulator. So what does this thing actually do? Well, it kind of has three main jobs. First, it stores up energy in the form of pressurized fluid, ready for those times you need a quick power boost. Second, it absorbs shocks. You know, when a valve slams shut, the accumulator soaks up that jolt. And third, it smooths everything out, kind of like noise cancellation for the pressure pulses coming from the pump. It just makes the whole system run better. So how does this magic cushion even work? It's actually a really neat three-step cycle. First, they pre-charge it with nitrogen gas to create that cushion. Then, as the hydraulic fluid gets pumped in, it squeezes that gas, basically charging it up like a battery. Finally, when the system pressure drops and needs a boost, the compressed gas expands and pushes that stored fluid right back out into the system. Simple, right?
And this visual shows it perfectly. So, on the left, that's your starting point. It's pre-charged, just full of nitrogen gas inside a bladder. Then, look at the right. The hydraulic fluid starts flowing in from the bottom, and it squeezes that bladder, compressing the gas. Boom, energy stored.
And here's the payoff. See how it works? When the system calls for it, that squeezed nitrogen expands, pushing the bladder back down and shoving the fluid out to do its job. It's just a super effective way to buffer energy exactly when you need it.
So, when you take a step back and look at all these pieces together, the hoses, the fittings, these accumulators, you start to realize something. The real genius of hydraulics isn't just one big idea. It's in all these little, often overlooked, unsung heroes of engineering.
I love this quote from a technical manual because it just nails it. The fact that these systems can be so strong and last so long, well, that's no accident. It's a direct result of smart design, really understanding the physics, and of course, that meticulous maintenance we were talking about.
When it comes right down to it, it's all about components like these. Perfectly machined threads, tough as nails seals, the exact right materials, that's what lets us safely control such massive power. They're the critical, invisible link between a person flicking a joystick and a machine moving a mountain. And they're what make our modern, powerful world possible.
Kinda makes you think, doesn't it? We just peeked inside the arteries of our machines. It makes you wonder, what other hidden forces, what other brilliant little bits of engineering are out there, quietly making our world work every single day?